Hi there, it's Mrs. Trombley with lesson 2.6. This is the last lesson in chapter 2. Finally, we're almost there. Today we're going to talk about how to solve two-step equations. The goal is still the same. We want to figure out what the value of the variable is that makes the equation true, that makes one side equal the other. And again, in order to find the value of the variable, our job is to isolate it. We want to get it by itself on one side of the equation. And we were already learning that in order to do this, we basically undo whatever's being done to the variable. So we try to cancel things out, whatever's being done. In this first equation here, the 2y plus 3 equals negative 9. Think about what's being done to the variable and the order that it's being done according to order of operations. So if we're looking at this, I see that the y is next to the 2. That means there's multiplication. And 3 is being added. So two things are happening. That's why it's called a two-step. The very first thing that we would do according to order of operations is multiplication, right? So y is being multiplied by 2. The second thing that's happening, after we've multiplied by 2, then we would add 3. So basically, in order to solve that, we want to undo what's being done, but we need to do it in reverse order. And order does matter. We know this about math, right? Order matters. It's just the way it is. It's just like a court of law. Order. So anyhow, that was a bad one. I know, sorry. If I'm adding 3, to undo adding 3, we learned to add a negative 3, right? Adding a negative 3 is what cancels out that positive 3, additive inverse. And we learned that when we had a multiplication equation, in order to undo multiplying by 2 to get the y by itself, we learned that we divided by 2. So we just did the reverse order. That's how you solve these things. So in other words, when you see, I'm going to write it over here, give myself some room, 2y plus 3 equals negative 9, I'll draw my line, and I don't want to get rid of this 2 first, I want to get rid of the 3 first, because I'm doing reverse order. And how do we get rid of that 3? We said right here, we would add a negative 3. When you add that negative 3, 2y plus 3 plus negative 3, those are like terms. Those equal 0. 2y is still left. Negative 9 plus negative 3 would be a negative 12. And then we see here, okay, I still need to divide by 2, because that's what's going to eliminate this 2 here. So y is by itself. When you divide this side by 2, 2 divided by 2 is 1, and 1y is y. And whatever you do to one side, do to the other, and you'd get your negative 6. So that's basically how you solve a two-step. You're going to change all your subtraction to addition by adding the opposite still. We're going to isolate the variable term first. So in this, do you see how we got 2y by itself first? That's what I mean by isolate the variable term. It's the term that has the variable with it. So isolating that first means get rid of the constant that's being added by adding the opposite of it. And then, it says here in step number 3, if you have a multiplication equation, you're going to divide both sides by the coefficient of the variable. And if you have a division equation left, then you'll multiply both sides of the equation by the number the variable is being divided by. So it's kind of like you're solving two one-steps. That's why I call it a two-step. So let's try a few. Zoom in here. Let's check your screen. All right. So, same thing. Subtraction, add the opposite. So this is really 4p plus negative 7 equals negative 15. I want to know what value of p will make this equation true, will make this side equal negative 15. We don't want to use guess and check because you're going to learn that takes way too long. Step 2 says isolate the variable term. That's the variable term. I want to get that by itself first. That means I need to get rid of this negative 7 that's being added. And you learn to get rid of things that are being added. You just do additive inverse and add the opposite of it. Adding 7 to this side will isolate 4p because those two cancel out. So 4p is left. This equal sign means they have to stay balanced. So if you add 7 here, we need to add 7 here. So negative 15 plus 7, that's negative 8. Right now, we're not done because the variable's still not by itself. What I have left here is just a little multiplication equation. And you learn that to isolate the variable in a multiplication equation, you just need to divide by the coefficient of the variable. So I'm going to divide both sides by 4. Notice we didn't change any signs, right? Because if you divided 4 by negative 4, wouldn't you get negative 1p? We don't want negative p, we want positive 1p. So 4 divided by 4 is 1, p is left, and negative 8 divided by 4 is negative 2. Now p is by itself, we know that we're done. You'll check these the same exact way you checked the others. We're going to replace the variable with the amount that we found for it. So if we're saying that p is negative 2, that means I'm going to take 4 and multiply that by negative 2, because 4 next to p means multiplication. And I want to add a negative 7 to get negative 15. Now if you just left this as minus 7 like the original equation, you know that means the same exact thing, so it's fine. Order of operations says we do multiplication first, so 4 times negative 2 is negative 8, and is negative 8 plus negative 7 negative 15? Yeah, when you add two negatives, you get a negative, and 8 plus 7 is 15. So we know that we're right. So again, you can still check every single one. Please do. All right, the next one, this also starts off as a subtraction, so we want to change our subtraction by adding the opposite. So keep, change, change. Don't change the sign of the number in front of the subtraction. You change the sign of the number that follows the subtraction sign. Please, please. All right, draw your line. All right, step 1, I want to isolate the variable term. That means I want negative 10x to be by itself. I need to get rid of this constant number that's being added. So to cancel out this negative 3 that's being added, we add a positive 3, because that's how you get rid of numbers that are being added. You add the opposite of them. A negative 3 plus a positive 3 equals 0, and 0 plus negative 10x, yeah, it's negative 10x. Over here we're left with 37 plus 3, which is 40. Okay, so we have a multiplication equation left. This is a little one step. To get x by itself, all you have to do is divide by its coefficient. So negative 10 divided by negative 10 is 1. 1x is x. And 40 divided by negative 10 is negative 4. Circle it to make sure that it's right. You can go back up to your original equation. Negative 3 plus negative 10 times, we're saying x is negative 4, is supposed to equal a positive 37. Let's see if it does. You can type that in your calculator too if you wanted, but honestly, if you know your multiplication facts and your integer rules, this will be faster. This means negative 3 plus, I have to multiply first, 40 equals 37. Does a negative 3 plus a positive 40 give you a positive 37? Yeah, because when I'm adding one of each, I have to subtract the digits and take the sign of the greater digit. The greater digit's positive. Alright, last one like this, and then yes, we do have another page of examples. I wish it were just this easy, but of course I have to show you some decimals and fractions. Okay, draw your line. Now we're going to change our subtraction to addition by adding the opposite, so that's now adding a negative 2. The variable term this time is n over 5. So this time it's going to be a division 1 step that's left over. Same first step though, isolate that variable term, the term with the variable in it, by adding the opposite of the constant. So negative 2, I want to get rid of that. That means I'm going to add a positive 2. Negative 2 plus positive 2, those are like terms. This is not. So those cancel out. They equal 0. And n over 5 is left. Negative 10 plus 2 is a negative 8. Alright, so now I'm left with a division equation. You learned that to isolate the variable in a division equation, all you need to do is multiply each side by whatever the variable is being divided by. That allows you to cross-cancel, leaving the variable by itself. So in this equation, n would equal negative 40. To check to make sure that you're right, just plug it back in. If we're saying n is negative 40, that means if you take negative 40 divided by 5 plus negative 2, you should get negative 10. Well, negative 40 divided by 5 is negative 8. And negative 8 plus negative 2, does that equal negative 10? Sure does. Same signs. Add the digits. Keep the sign. So that's the gist of a basic two-step equation. Turn your page and let's try a few with fractions and decimals so you can see that there's nothing really different about this. They might take a little bit longer if you're not using your calculator, but you solve them the same way. So don't freak out the second you see decimals. Do what you do. Draw your line down from the equal sign to separate one side from the other. change your subtraction to addition, and let's move. So we see here's our variable term, right? That's the term that has a variable in it, and your first step is always to get rid of the constant, get rid of the number being added to the variable term. Well, right now, -3/100 is being added. To cancel out a number that's being added, you just add the opposite of it. So I'm going to add the positive version of that. And whatever you do to one side, you have to do to the other. So this -3/100 and +3/100 equals 0 when you add them. And you're left with 1.4n. And then here I see I have one of each. That means I need to subtract the digits and take the sign of the greater. So I have more negatives than positives here. So that would be -11 and 62/100. 5 minus 3 is 2, 6 minus 0 is 6, 11 minus 0 is 11. We're not done, right? Because the variable is not by itself. And that's the goal of solving your equations, is to get the variable alone. So how do you get 1.4 to go away when it's being multiplied by n? You divide by it. So I'm going to divide both sides by 1.4. That leaves n by itself, because 1.4 divided by 1.4 is 1, and 1n is n. And now I would just grab my calculator and type in -11.62. I could do this a long way, you know this, and I wouldn't even mind, but I don't want your video to be 30 minutes long. I'm shooting for 20 or less. So when you divide these two, I know it's going to be negative because I have one of each and I'm dividing, and you'll get -8.3. You will also check this the same exact way you check the others. It says 1.4 times n. So that means I'm going to take 1.4 and multiply it by -8.3, because number next to letter means multiplication. And when you add -3/100 to that, we're supposed to get -11.65. So I grab my calculator, type in 1.4 times -8.3, add -3/100 to that, and lo and behold, you do get -11.65. So we know that it's right. It just takes a second, and you can check every single one and know that you're right. It's a beautiful thing. All right, this next one, we have a fraction in it. Solve it the same way. Fraction does not mean freak out. Fractions are fun. And the opposite here. I'm going to put it with the numerator. Okay, this is the variable term. That's a term with a variable in it. Your first step is to get rid of whatever constant terms being added to the variable term, right? So this -1/2 has to go. How do you cancel out a number that's being added? You just add the opposite of it. So the opposite of a -1/2 is a +1/2. So I'm going to add a +1/2 to each side. -1/2, +1/2, when you add them together, you get nothing. You're left with x over 8. Now here I have -7/2 plus +1/2. Remember that when you're adding fractions, I suggested taking that negative and putting it with the numerator spot so we can keep our like denominators in this case. So we have like denominators. That means add the numerators. So -7 plus 1, that gives me -6, right? I'm going to bring over my 2. And I have -6/2. Now, I'm hoping that you're thinking to yourself, well, I wouldn't leave it as -6/2. This is equal to -6 divided by 2, which is -3. So what I'm really left with here, I'm going to rewrite it, is x over 8 equals -3. We're not done. We have one more little thing to take care of, right? Because x is being divided by 8 and we need x by itself. So to get rid of dividing by 8, to cancel out that 8, I need to multiply each side by 8. That allows me to cross cancel. And x equals -24. Bam! To check it, you do the same thing. Plug that -24 in for x. Rewrite your original equation. And see if you get the same thing. So -24 divided by 8, that gives me -3. And -3 plus -1/2, that's -3.5, right? If we change this improper -7/2, wouldn't we get -3.5? Yeah, 2 goes into 7 3 times, 1 left over out of 2. So it checks out. It works. All right, one more fraction one. This time I gave you a fractional coefficient one, just for kicks. All right, draw your line. This is already addition, so I don't need to do anything to it. My variable term this time is -5/11h. That's the term that contains the variable. I want to get rid of what's being added to that first. To cancel out a 7/9 that's being added, I'm just going to add a negative 7/9. Those equal 0 when you add them together. I'm left with negative 5/11 h equals, and again, I gave you like denominators. Doesn't that make you so happy? So all we need to do when I have a like denominator I'm adding, bring over your denominator and add your numerators. 2 plus negative 7, that's negative 5. All right, we're not done. It would be great if we were done, but we're not. We need to get rid of this fractional coefficient. In the last lesson, I talked about how all you have to do to get rid of a fractional coefficient is multiply by the reciprocal, right? And we discussed in class, and I'm sure that we did, that multiplying by the reciprocal is really the same thing as dividing by the coefficient. I know you don't need to write down what I'm writing, but if I gave you, let's say, 3/4 divided by 1/2, wouldn't you keep, switch, and flip that to solve it? That's how you solve division of fractions, right? So if we have negative 5/11 times h, and you're saying, well, Mrs. Trombley, why am I multiplying by the reciprocal? Why can't I just divide by negative 5/11? Because it's a multiplication equation. Well, if you took negative 5/11 divided by negative 5/11, yeah, that equals 1. But when you divide fractions, don't you do keep, switch, flip? So dividing by that fraction is the same thing as multiplying by its reciprocal. That's what happens. So what I'm really doing by having you do this is skipping a step. I'm giving you a shortcut. If you feel better about writing divided by negative 5/11, divided by negative 5/11, and then doing your keep, switch, flip, you'll get the same answer with an extra step. I don't mind. It's fine. Whatever helps you out, whatever helps you to understand what you're doing. All right, so I want this fractional coefficient to go away. I'm going to solve this by multiplying by the reciprocal. So the reciprocal of negative 5/11 would be negative 11/5. So I'm going to multiply this side by negative 11/5. Negative 11/5 times negative 5/11, when you multiply those, negative times a negative is a positive, you get a positive 1h, which is h. On this side, right off the bat, I see I have a negative multiplied by another negative. That means it's going to be a positive answer. Great. I also see that I have a 5 here and a 5 here, which allows me to cancel it out. That's awesome. So I'm left with 11/9. And it's positive again because a negative multiplied by another negative is a positive. And yeah, I would prefer you to write this as its mixed number. So 9 goes into 11 once, and there's 2 left over out of 9. All right, I know that one was a bear. I won't give you like 100 of those or anything, maybe 1 or 2 to make sure you know what you're doing. All right, last but not least, and they look worse than they really are. These aren't going to take too long. Sometimes you have to simplify an equation before you can solve it. We learned how to simplify expressions by combining like terms and removing parentheses. Sometimes you need to do those things before we can solve it. So looking at your equations, I want you to look on either side of the equal sign to see, are there any parentheses, are there any like terms? Take care of them, and then you'll change it into an equation that you recognize. So take a look at this first one. I'm sure that you'll see, oh, this is an equation. I'm going to draw my line. I'm going to change my subtraction to addition. And then you might say, well, wait a minute. There's 2 y's. How am I supposed to do this? Well, you're not. You're going to change it into an equation that we recognize. So if you see that on this side of the equal sign or on this side of the equal sign, because you can't combine them through the equal sign, that you have some like terms, combine those first. Here's what I mean. On this side, you have 3y plus negative 8y. Those are like terms. I'm going to add their coefficients to get negative 5y. And over here, it stays the same. I didn't change anything. I didn't add anything to this side to make it heavier, so I don't have to do anything to this side. All I did was combine what was already there to make it simpler. Simplifying isn't changing values. All right? Dividing by negative 5, that would change the value. So at this point, I'm hoping that you see, oh, this is just a little one-step equation. It's multiplication. Divide each side by negative 5, and y equals 5. Bam, you're done. So like I said, it's not really that bad, right? To check these, you're going to check it the same way. I'll go back to my original equation, except this time I'm going to have to put y in there twice. So if I'm saying that y is 5, that means I'm going to replace this y with 5 and that y with 5. So when you take 3 times 5, that's 15. And when you take negative 8 times 5, that's negative 40. And when you take 15 plus negative 40, do you get negative 25? Yeah, subtract the digit, sign of the greater digit. That's right. So we check these the same way. All right, let's try this one. Draw your line. Okay, this one I'm going to keep change wherever I see it. And I don't have any other y's, but do you see how you have two constants? Those can be combined. So again, ignoring what's on this side of the equal sign, you're combining like terms on either side of the equal sign. So the 4 and the 3 can go together, so I can rewrite this as negative 2y plus 7, or if you wanted to write 7 minus 2y or 7 plus negative 2y, you could. It all means the same thing. And now at this point, we recognize this as, oh, this is a two-step equation. I remember that. We just did that like 5 minutes ago. I want to isolate the variable term. That means I'm going to get rid of this constant by adding the opposite of it. I'm left with negative 2y. A negative plus a negative is a negative. 9 plus 7 is 16. Now I have a nice little one step. To undo multiplication, we divide. We don't change any signs. And negative 16 divided by negative 2 is 8. To check it, plug an 8 in for the y. All right, we'll do lots of checking practice in class. I'm just going to get these done. All right, draw your line. Add the opposite. This time, I don't see any like terms on either side of the equal sign, but I do see some parentheses. That needs to be simplified before we start. So expressions in simplest form don't have parentheses. So we're going to distribute the 3 to everything inside. That means that this is really worth 3x plus negative 12. And now again, we're back to the two steps. Don't forget to distribute the 3 to everything inside. All right, so I'm going to add 12 to each side because my first step is to isolate that variable term. We did. It's 3x. And when you take 9 plus 12, we get 21. We're left with a little multiplication equation. To undo multiplication, we just divide. And x equals 7. You can check this the same way. Plug a 7 in there. 7 plus negative 4, that's 3, right? And 3 times 3, that is 9. We know that we're right. Lovely. Last one. All right. Draw your line. Let's get rid of these parentheses. Negative 7 times y is negative 7y. Negative 7 times 8 is negative 56. And we're left with negative 35. All right. Isolate this negative 7y, so I'm going to add 56 to each side. We are left with negative 7y, because when you take negative 56 plus positive 56, it cancels out. It's all gone, so negative 7y is left. And when you take negative 35 plus 56, you have to subtract the digits and take the sign of the greater digit. So 56 minus 35, that's 21. I have more positives than negatives, so my answer is positive. To finish this one off, all you need to do is divide by the coefficient of y. Again, not changing any signs because my goal is to get a positive 1y. If you have one of them being negative, the other one needs to be negative when you divide. 21 divided by negative 7 is negative 3. Negative 3 plus 8 would be 5. And 5 times negative 7 is negative 35. So we know that we're right. It's awesome knowing you're right. I'll see you tomorrow.